Nightmare Eclipse strikes again, dropping another 0-day in Windows Defender that can escalate you from any user to system. Not a great thing for Windows. Who is Nightmare Eclipse, you may ask? Great question. So, story goes back to Nightmare Eclipse a couple months ago where this person came out and said, hey Microsoft, screw you guys. Here's a couple 0 days for y'all to deal with. Sorry, not sorry. The backstory goes that Nightmare Eclipse apparently used to try to work with MSRC, the Microsoft Security Response Center, to get paid for their exploits. They didn't get paid for some reason or another, and then because they were mad at Microsoft, they dropped these 0 days. Some time went by and Nightmare Eclipse dropped more and more 0 days on GitHub, causing them to get banned from GitHub, and their blog to actually get flagged by Google on Blogspot as a malicious malware blog. So now Nightmare Eclipse has moved off of the Blogspot blog, and they have their own private Git server where you can download the latest version of their exploits, Rogue Planet. Now, Rogue Planet, like the majority of Nightmare Eclipse's exploits, are exploits that allow a user that is locally on a Windows box to escalate from a standard unprivileged account to NT authority system. It is basically like almost the highest privilege you can go. I think technically like trusted installer is like the highest, but NT authority system is like basically you're good to go. You can do whatever you want on that box. You are root effectively on Windows. It was published on June 10th, 2026, and it takes advantage of several issues in Windows Defender, the antivirus it ships with your Windows box. It's specifically the real-time scan and quarantine pipeline. It's exploiting this thing called a time of check, time of use vulnerability in Windows Defender. Now, the idea behind a time of check, time of use vulnerability is actually very simple. You've probably heard this called as a race condition. This is like a more specific application of the race condition scenario, but effectively it boils down to this pattern, right? So we have the checker, and the checker is trying to make sure that something provided by the attacker is not malicious. And so for this example, we are only allowed to present to the checker squares, not circles, okay? So what the checker is gonna do is wait for the attacker to put something down, and the attacker is a good boy and he puts down the square, and the checker looks at the square and says, yup, that's a square. I'll take some action on the square, okay? But the checker has other work to do. The checker says, but before I do that, I'll be right back. So the checker looks away. He looks over here for a second, and the attacker still retains control over this slot, right? The attacker has not been revoked permission to touch the slot. And while the checker isn't looking, the attacker goes back and replaces this with a circle before the checker looks. The attacker has replaced the square with a circle, and now the checker goes back and performs the action on the object, not rechecking that it is in fact a square, not a circle. Because the attacker still had access to this slot, there was a time in between the check and the use, time of check, time of use, that allowed the attacker to insert a thing it was not supposed to and allow the checker to do something malicious on its behalf. This is the race condition. This window, when the checker is looking away, is a race for the attacker to take the square, remove it, and replace it with the circle, the circle being the evil object. This pattern is all over Windows Defender, and it's exactly what Nightmare Eclipse is exploiting. So the way this exploit works is like really friggin' genius. I'm gonna call this RP because I don't want to write out the whole word, okay? So what Windows Defender's job is to do is literally to take malicious files, to scan them for malicious content, and if they are malicious, quarantine them, and if they're not malicious, put them back, right? Very simple antivirus behavior. And obviously Windows Defender is over here running as system, okay? So it has intently, it's an antivirus, extremely high privileges. The way Rogue Planet works is the user, the attacker, presents a file over an ISO that is mounted into the device, right? It's like a disk image. You can mount this disk image as a virtual disk onto the CPU. Now inside of this ISO is this file called manager.exe. This is the Windows event manager. It's spoofing effectively this exe that Windows is already aware of, that already exists on Windows. It's gonna be the string called the eichar string or the icar string. The icar string is literally just a string that exists to intentionally make antiviruses do things, okay? We're going to say, hey, this icar string exists inside of manager.exe, which triggers antivirus, which triggers Windows Defender to go and take some action on that file. But before we do that, what we're gonna do is make an alternate data stream, an ADS on the file, which if you're familiar with NTFS or any like the Windows file system internals, this basically is a way to treat one file on Windows as multiple files, and they have basically like different names appended to the file. You can put data for the actual file in the main data stream, and you can put other contents in the alternate data streams. Now in Windows, you can also apply these things called op locks, an operational lock that basically says, hey, before anyone else touches this file, I need you to notify this program, for example. So we're gonna put an op lock on the alternate data stream, and then we're gonna get Windows Defender to try to scan this file. What this will do is this will notify the Rogue Planet malware that the Windows Defender system is trying to touch the file, which is good. We want to know exactly when this occurs. Now, it's important to note that all this scanning is being done inside of this folder temp rp underscore some GUID, some random string of characters, slash system32, and then at the end of this folder is where the actual wordmanager.exe is going. Again, the attacker controls this directory. It is a completely arbitrary temporary directory that the attacker controls. And Windows Defender is scanning the wordmanager file inside of this folder. Now remember, we have an op lock on this file, which means we are being notified, we, the attacker in this scenario, we're being notified when Defender is doing a read operation or something on this file. So what we now know is we can see when Windows is looking at it for scanning to see if it's a malicious file, and we know when it's trying to read the file to put it back. So all Windows has done so far is scanned our file. How can this be malicious? Well, when we're done scanning the file, if it's found to not be malicious, Windows Defender is gonna put it back where it found it. And in this case, where it found it, this will change here in a minute, is just this temp folder, okay? So what we're gonna do first is wait for Windows to scan our file to see if we're actually malicious. This is Windows looking for that icar string, right? At this point, we have the icar string. We're actually going to, before it gets to read the icar string, just put a normal piece of code in there. Normal code, normal data, so that Windows says, oh, wait, this file is actually not malicious. We don't care about this. What we're actually gonna do is temporarily point this file back to the one in the ISO, the original copy that is read-only that we didn't change. But then Windows is going to try and put wordmanager back into the disk. It's gonna try to put it back to temp rpg system32. And this is where we're gonna activate another op lock and do this insanely weird feature that I really don't understand why it exists in Windows, called a directory junction. A directory junction is literally like a Unix symlink where I can make one folder point to a different folder. But the thing is, I don't need to have the ability to write to the other folder, right? Because the attacker owns this folder here, system32, I can literally just make this system32 folder be an NTFS junction to the actual C/Windows, not gonna write the whole thing, /system32. What will this do? Well, when I see this occurring before the op lock gets released, I'm going to replace the context of wordmanager.exe with my arbitrary code. I'm gonna write whatever code that I want into that file before it gets put back into system32, which, by the way, the file in system32 is being ran as a service as system, which means that we can arbitrarily change the contents of this file, which does Windows event reporting, to be whatever we want and have it be ran as system. And that's exactly what Rogue Planet does. I'll link the code for the vulnerability and also the blog post that I read to kind of get more familiar with it in the description below. But this thing we're doing here, where we have another process that is a higher privilege doing something on our behalf, is the classic confused deputy problem, right? We have this issue where a process, we know it's going to take some kind of action. We have a way through an op lock to kind of be told when the action is being taken. And so we have this time of check, time of use, where there is a delta between the time of check on if the file is normal, between the time of use of it actually writing it back, where we can use that window to change the contents of the file and write that file to disk. Now, again, a time of check, time of use, a lot of the times the race condition is very, very tight, like microseconds, a couple of clock cycles in your CPU. But if we have an op lock, a functional piece of the OS that we can tell the OS to hold and notify us when an operation occurs, we can make this window significantly larger. We can make it on the order of, well, actually, we can make it as long as we want. And I know what you're thinking. Surely Rust fixes this. No, Rust is really good at preventing memory corruption issues that are related to out of bounds reads or writes, or doing things that enable use after freeze, right? It fixes this whole problem with ownership and the ability to kind of hold on to whose job it is to free a file, right? But time of check, time of use is a more higher level, like logic issue, right? In the timing of when things are checked and accessed. So you can very easily write insecure uses of these kind of systems. This example here is an okay one, but basically kind of the same idea as like the box and circle checker thing. If we don't do the check and the read of the file atomically, right, it is possible that the file name or the file we're trying to open can be changed to a symlink of a different file that the attacker wants us to modify, and we didn't do that check in the same time, right? We didn't atomically hold those things as one operation, we did them twice, and so there is this window right here where we leave up time for the attacker to do something a little more malicious. Whereas in the secure example, this is using a single operation that I'm assuming is atomic, meaning it's done at once. By doing it at once, there is no window for the attacker to swap out the file at one time, right? I don't know how this function works internally. It may not actually end up being atomic, but that being said, like, this is a general idea if this confuses you. And no, Rust does not fix this. If you're still here, thanks for watching. Sign up for my newsletter. I have a newsletter that goes out every week that talks about things like this, kind of gives you the updates on the exploitation world and what Nightmare Eclipse is doing and what MSRC does in response. So if you're into that, check it out, lowlevel.tv, and then check out this other video that I think you will also enjoy probably as much, I hope.
Say the line, Bart.
Surely Rust fixes this.
Yeah!